Hello everyone, in this video we will cover the section 1.3. In this section we will classify the differential equations. First we will classify the differential equations by finding its order. The order of a differential equation is the order of the highest derivative that appears in the equation. Generally, a differential equation can be given mathematically as capital F of t u prime blah blah. The nth derivative of u is equal to 0 implicitly. Namely, we can consider a differential equation as a multivariable function such that every different term in the equation can be considered as a variable. Okay, like t, u of t, the first derivative of u, the second derivative, third derivative, and so on. Every of them will be a variable for this capital F. Or instead of the function u of t, we can write just y prime, y prime 2, and nth derivative of y is equal to 0. For example, we have the second derivative of y minus x times y prime plus 5 is equal to 2 minus t, for example. Writing these terms into the left hand side, so we can write 2 minus x, we consider the independent variable as x. So we have the second derivative minus x times y prime plus 3 plus x is equal to 0. When we look at the left hand side of the equation, actually it can be considered as a function of 3 variables such that the variables are x, y prime, and the second derivative of y is equal to 0. Okay, x, y prime, and second derivative. By considering them as a variable, so we have a function of 3 variables, and right hand side is equal to 0. Such this example, we can consider every differential equation in this form. Okay, so this is a general formula for an ordinary differential equation of the nth order. What is the order of this differential equation? This is the second order ordinary differential equation, because we have the second derivative, which is the highest derivative of the dependent variable, and it is an ordinary differential equation because we have only one independent variable, which is x. Another example here is given. The third derivative is equal to function y. So the order of this differential equation is 3, and this is an ordinary differential equation. When we look at the second, the order of this differential equation is 1, because we have just first derivative of the function g prime of t is equal to 3 times g plus sine times g plus cosine t. When we look at the next one, the order is 2, because the highest derivative of the dependent variable is given by x2 prime. You see the second derivative of the variable x with respect to s. Here the dependent variable is x, the independent variable is s, and x, the first derivative to the power 4. The order is not 4 because it states the power of some function. Therefore, just we will look at the level of the derivative for the dependent variable to describe the order of the differential equation. Therefore, the order is 2 for this one. The second type for classification of differential equations is to find ordinary or partial differential equations. You know, actually, this classification in the preceding sections, This is an important classification which is based on whether the unknown function depends on a single independent variable or on several independent variables. In the first case, only ordinary derivatives appear in the differential equation, and it is said to be an ordinary differential equation since we have a single independent variable. Therefore, just we will see the derivatives of the function with respect to this single independent variable. In the second case, the derivatives are partial derivatives since we have a multivariable function because the number of independent variable is bigger than 1. And the equation is called a partial differential equation because of this reason. An example of ordinary differential equation is given in this form, for example. This represents a mathematical model for some problem in nature. So you see the independent variable is just t, and we see the derivatives of the function q with respect to t, and every function is depending on a single variable, independent variable t. Therefore, this is an ordinary differential equation, and its order is 2 since we have second derivative of the function. Here we have another example which states a typical example for partial differential equation. So you see we have the second partial derivative of u with respect to x, and also we have the partial derivative of the same function u with respect to t. We have two different independent variables x and t. Therefore, it is a partial differential equation. It is an example of partial differential equation. And another mathematical model, which is the wave equation, actually the same equation, just we have the difference on the right hand side. We have the second partial derivative of u with respect to t, and since we have two independent variables for the solution of the differential equation u of x of t, it is a partial differential equation. And another type of the classification of the differential equation is to find whether a differential equation is linear or nonlinear. So it is obtained for ordinary differential equations, and hence ordinary differential equation is said to be linear if it is a linear function of y prime blah blah, the nth derivative of y, which is in the form, generally mathematically you can see, if you have this form for any ordinary differential equation, so it is called linear ordinary differential equation. Namely, the coefficients are functions of t. The coefficients are functions of t, and we have the nth derivative, n minus 1 derivative, blah blah, and a n of t times y is equal to f of t. It is similar to the statement of the polynomial, if you remember. Instead of x to the power n, we have the nth derivative of the dependent variable. An equation that is not of the form above is a nonlinear ordinary differential equation. And also we have another special case for linear differential equations if the right hand side, namely f of t, is equal to 0. If f of t is equal to 0 in the general form of linear ordinary differential equation, so then it has a special name which is called homogeneous differential equation, and then it is called homogeneous homogeneous differential equation. So you see some examples about that. When we investigate the first equation, y prime is equal to 3 times t square. What is the order of this differential equation? It is 1 because we have the first derivative just of the dependent variable y. Is it linear differential equation? Yes. When we look at the general form, f of t is 3 times t square, and here actually we have y prime plus 0 times y is equal to f of t. Therefore, a1 is 1, a1 of t is 1, and a2 is 0. Namely, the coefficients are considered as a function of t, which are constant functions, and it is of the form of the linear equation. Therefore, it is linear differential equation, and it is ordinary differential equation since we have a single independent variable. Is it homogeneous? No, because the right hand side of this linear ordinary first order differential equation is 3 times t square, which is not equal to 0. Therefore, it does not satisfy the condition of the homogeneous differential equation. Therefore, it is not homogeneous, but it is linear. The order is 1, namely this is the first order ordinary linear non-homogeneous differential equation. Similarly, when we look at the second example, the order is 2 since we have the second derivative of the variable, dependent variable. It is ordinary differential equation. Therefore, this is second order differential equation. It is linear because the coefficients are considered as functions of t. When we look at the coefficients of the derivatives of the dependent variable y, and it is non-homogeneous differential equation because the right hand side is not equal to 0. Okay, and when we look at the third one, the right hand side is 0. The coefficients are constant functions of t, and it is of the form of the linear differential equation, and it is second order ordinary differential equation. Therefore, it is homogeneous second order linear differential ordinary differential equation. When we look at the next one, the order is 1 since we have the first derivative. Is it linear? No, because when we look at the coefficient of the first derivative, we have the variable y, which is the dependent variable, but according to the definition, the coefficient should be a function of t, but y is the dependent variable, not independent variable, because the coefficient should be a function of t, like 4 times t, or can be t squared, or t to the power 3, or t squared plus 2, and so on, any function of t. Since we have the dependent variable for the coefficient of the first derivative, it is non-linear differential equation. Since it is not nonlinear differential equation, so we don't need to look at whether it is homogeneous or not, because homogeneous equations are a special case of the linear differential equation. Therefore, it is not applicable. When we look at the next one, similarly, the order of the differential equation is 3 because we have third derivative of the variable y from here, and it is non-linear differential equation because we have square root for the third derivative, according to the definition, we don't have any operation for the derivatives of the dependent variable, but here we have root function for the highest derivative of the dependent variable. Therefore, it does not satisfy the definition of linear ordinary differential equation, and therefore we don't need to look at the differential equation for homogeneous or non-homogeneous condition, and so on. For example, we have tangent t here. The left hand side satisfies the definition of linearity, but it is not homogeneous differential equation, since the right hand side is not equal to 0, which is equal to tangent t. It is linear because it satisfies the equation of the general form of the linear differential equation, and the order is 2 since we have the second derivative, and so on. You can increase the example to understand very well. This is the classification of the differential equations with three types: order, linear or non-linear, homogeneous or non-homogeneous. We have three types for the classification of the differential equation. Thank you for listening.